Okay. For just take this one as letter A, B, C, D, E, and then F. Okay. So for letter A, explain how an object can have positive acceleration and positive velocity. Well, object should be moving. Object moves in positive direction with increasing speed. So that means that the magnitude of velocity increases also. That's what happens there. You have a positive acceleration and negative velocity. So negative velocity. So in this case, object moves in negative direction. So it could be south or east or west. Okay. So negative direction. And if you have noticed, uh, even for the position time graph and the velocity time graph, the magnitude decreases, so it slows down. Okay. Then you can see in that particular case that then moves in positive direction. Your answer could be different, but in essence, it should be the thought should be the same as this one. So negative velocity, positive acceleration. So you have it moves in the negative direction, but the magnitude of that velocity decreases until such times that it went back and moves in the positive direction with an increasing velocity afterwards. Okay, but you can just disregard the last phrase here. That's still okay. That means that at least in that particular case, you see that if you have a positive acceleration and negative velocity, both have different directions, the object slows down. Because actually, this is the same thing with letter C. Negative acceleration, but positive velocity. So it only says that the object, if you can observe with that one, moves. So the object moves in positive direction, but slows down. Okay, maybe you can just stop there, or you can extend it and then moves in the negative direction. Okay, then then goes in the negative direction. Because later on we will try to generalize these things. They are answers. So if you can see here, letter D is negative acceleration and negative velocity. So if you can observe where their position time graph as well as the velocity time graph, the object moves in negative direction. It moves in the negative direction, but moves in the negative and faster. Okay. So the magnitude increases. It's just that it's moving in the negative direction. So it moves faster. If you can see the magnitude, again, don't take the values of your negative velocity as a lesser number. Again, the negative sign in your velocity time graph only tells you that it's moving in that direction. But essentially, its magnitude or the size or the magnitude of that velocity is also bigger as you move to the left, or again it's more if it's becoming more and more negative, because the negative sign there only indicates its direction. So essentially it moves in the negative direction, but it moves faster because if you can see the value of that increases. Okay. And letter E, you have here zero acceleration and negative velocity. So zero acceleration and negative velocity. Well, zero acceleration means that it's just moving with a constant velocity. Object moves in the negative direction with same speed. Remember that when I say speed, it's just the magnitude of the velocity. So if you can see there, that is just a straight line graph in the velocity time graph. Okay. And letter F, negative acceleration and zero velocity. So it just tells you that the object is initially at rest. At rest, then speeds up in the negative direction. For all of these questions here, you can actually deduce this one into two. Like, you can think of velocity and acceleration having the same sign. So just like in the case of letter A and letter D, right? And in a case wherein the acceleration and velocity have different directions, okay? So in that particular case, you can summarize your results here as, well, looking at their directions. So you can say that when the acceleration and velocity point in the same direction. So again, that's the yellow case there, the yellow highlighters that I point out. So the acceleration and velocity are in the same direction in the particular case. The object will speed up in that direction. Okay, so that means that you should expect that the magnitude of your velocity increases. But for the direction part, well, it depends on the direction of your velocity. Again, that is the first case. You have the same direction of your velocity and the acceleration. The other case is that when A and V point in different directions, okay, you can expect that the object will slow down. Okay, so again, slow down means that it would decrease, the magnitude of its velocity decreases. Okay, and actually, if you're gonna ask why is it that particular case, well, the explanation for this one would be answered when we talk about dynamics. So example number 4. Car is traveling south at 16 meters per second. And if the car accelerates at a rate of 0.5 meters per second squared south for 7 seconds, what would be its final velocity? Again, first I will define my positive direction as the north direction. So first I will identify my given quantities. That would be my initial velocity. It's moving south, so therefore it's negative. So the convention that I'll be using is a negative direction. And then the acceleration is also south, so therefore it's negative 0.50 meters per second squared. And then given the time, or the time elapsed, delta t as 7 seconds. And then I'm trying to find for the final velocity. So now for my solution, based on the things that I know or the given quantities, I can use the acceleration equation, which involves change in velocity, or the final minus the initial divided by delta t. Or if I gonna uh, uh, derive the expression for VF, that would give me VF is equal to A times delta T plus the initial velocity. So I'm gonna substitute the values now, the things that I know. A is negative 16. No, A is not negative 16, but negative 0.5. So that would be negative
0.50 multiplied by the time, then plus the initial velocity of negative 16. If I'm gonna multiply this two, this will give me uh, 3.5, negative 3.5. So 7 is just one sig fig, so this should be negative 4 plus the negative of 16. So this will give a negative 20 meters per second. And to express my final answer, well, in two sig figs, that's 2.0 times 10 to the power of 1 meters per second. Then the direction is south. South is from the fact that I got a negative direction.